Hi, welcome to our pre-calculus. The topic today is using trigonometry to find angles of elevation or depression in a word problem. Several issues to discuss here aside from the mathematics. First of all, what is meant by elevation or depression? That is main question in all these problems. So let's just consider the following situation that we have the horizon, we have some object, and then another object. So A and say B. Now we could be standing at A looking at B, or we could be standing at B looking at A. So if I have a situation like this, that I'm standing here and I'm looking at B up here, B perhaps a bird or airplane or a kite or something. Angle of elevation refers to this angle. This is the way you tilt your head up to look at whatever it is you're looking at. Sometimes you are in the opposite setting, that you are here and so you're at location B and you're looking at location A. Perhaps you're in an airplane or a balloon up here and this is where you want to land or something like this. Then angle of depression is what is I'm drawing here. This is the depression angle. So in these problems we are aiming to find these two angles. Now next question up is mathematics of these problems is kind of very short and minuscule compared to understanding what the problem is talking about. Now it so happens that in all of the problems in this section the software is being nice to you and draws the picture for you. But I want you to do the following, that cover up the picture and try to understand the wording and draw the picture yourself. So for that reason I have kind of censored the picture here and just have the word that the words that describe the problem themselves. Why do I do that? Well, because this is what you're going to be encountering next semester and also in much of the engineering career that you're going to have ahead of you. That is, they don't draw the picture for you. They expect you to understand the description or to come up with a description related to a picture. So let's go ahead and practice this, and I want to ask you to do the same thing. Here's the first problem. A plane is 111 miles north and 193 miles east of an airport. Find X, the angle that the pilot should turn in order to fly directly to the airport. Round your answer to 1/10 of a degree. So in this case we have a geographical problem that is referring to north and east and south and west and so on. So typically you see a picture like this. In this picture it's supposed to be an airport. Let's suppose the airport is here. Everything is being measured with respect to airport, so that's why it tells me the airport better be center of the picture. Well, we are talking about the north and east, so on our picture we have to have a way of describing these things, so we better have a north, and of course the opposite direction is going to be, so this is the north of the picture and this is the south of the picture. And then it is also describing typically they draw east and west in the following configuration. So we are 111 miles north. What does that mean? 111 miles north, it essentially means this distance is 111. And 193 miles east. So in the east direction we are going to go 193 miles east. So the airplane is supposed to be here. So this is the location B, this is my location A, this is the airport. Luckily, airport starts with letter A. So we want to go, it says find the angle the pilot should turn in order to fly directly. So you hope the pilot wouldn't just abruptly go to that, but that's what we are after here. We want to find this angle, the angle at which we are supposed to turn. It says angle X, let me call it theta, so that we don't confuse that X with the X of an X-axis or whatever. It's some angle, so I just changed that to theta. And now the problem. So we took this set of words here, we described to the picture. So we have the words here, so it's a word problem, and then now we have a picture problem. The main difficulty of these problems is converting the set of words to a given picture. That's your main challenge, and I want you to practice that and not to rely on software making this thing into a soft problem by doing half of it for you. So once you convert it to a picture, then from there is downhill. It's very straightforward, because now you have the set of problems we had in the previous lecture. You have this triangle, this is theta, this is 193, this is 111. So what set of relationship connects these three items to each other? Easiest one is tangent. Tangent of theta is a ratio of opposite. So the opposite of this angle is 111. The adjacent is 113. And so theta will be a tangent inverse of 111 to 193. You use that calculator that so don't use your calculator. Use the calculator that is provided by Alex. You want to figure out how to enter this. You want to round the answer, and you want your calculator to be in degrees. So you want to watch out for all of that, and then you'll be good to go. Next topic, next problem is issue of we have a ladder. This is how long the ladder is. So what I want you to do to stop this video, solve this problem, and then come back and compare your picture, and then compare the final step. So this ladder is leaning against the house. So we have some house, perhaps better looking than what I drew. So we have a ladder that is resting against this. So I guess I should say don't do this at home. But anyway, this is 17 foot long ladder. That is a pretty long ladder. The bottom of the ladder is 9 feet away from the home. The bottom of the ladder, so the bottom of the ladder would be this one. So this is my A, perhaps. This is my B. Bottom of the ladder is 9 feet away from the house. Find X, the angle of elevation. So you see the angle of elevation. What is that angle of elevation? Okay, so if you're down here looking up at some window or some broken tile or something up there, you are going to turn your head up at a certain angle. That's the angle of elevation. So what we have now, okay, so here we went through the translation. Translation meaning, well, from one language to another one. What language here is? A language is a set of words, and what's the language here is a picture. And that translation is the high point of these problems. Again, mathematics of these problems is minuscule compared to understanding the intention of the problem. So you have to kind of work on your focus, push other things out of your mind. Just focus on the problem, become a friend of the problem. Don't try to get rid of a problem, rather try to become a friend of the problem. And then the translation comes to your mind, and then the mathematics from there is downhill. So the translation, this is 95% of, let me kind of push this issue, that you want to go through that translation. Okay, once you're there, what is next? Well, what trig relationship connects this angle to this and that? Well, this is right next to it, so it's adjacent, and this is hypotenuse. So we are going to have cosine of theta is 9/17. So theta is cosine inverse of 9/17. And again, you want to round it to the nearest tenth, and you want to make sure your calculator is in degrees, and then you'll be all good to go. Type 3. A ramp is 23 feet long and rises to a platform that is 18 feet off the ground. 18 feet is quite high. Sometimes you rent a rental truck, and so you have a ramp, and that goes up maybe 3 feet, and that helps you push the dolly up into the truck and so on. This is kind of very steep ramp. I'm not quite sure who uses a ramp like this, but well, that's what the problem is telling us. A ramp is 23 feet long, so this is 23 feet long, perhaps more like a ladder, to a platform that is 18 feet above the ground. 18 feet above the ground. That's what it means. Find x, so we change that to a theta, the angle of elevation. So if I'm up here and I want to push something up and I want to go up there, at what angle do I go up the ramp? Pretty steep ramp here, but we are not promising that these are practical situation, I guess. So perhaps more of a word problem than a word problem. Anyway, so what relates these three to each other? We have an angle, this is opposite, this is hypotenuse, so I'll have the sine of theta. Sine of theta relates opposite to hypotenuse, so theta is going to be sine inverse of 18/23, and so make sure you're in degrees and then round carefully, and then you should be good to go. Oh, we have one more, but this is again a ladder problem. So we have a house. It looks like a cubicle. The ladder is 16 feet long, so I'm putting a ladder to side of a house, and that is 16, and let's suppose this is level. The top of the ladder is 14 feet above the ground. Remember the previous problem, the distance from the house was given. This is we are told that we are 14 feet above the top of the ladder. So this point B, it's point A, and let's call this thing, say, H or whatever. So this is 14. Find the angle theta, angle of elevation. Angle of elevation, so we mean this one as opposed to, say, this one. So we have to be clear as to what quantity we are actually measuring. Mistakes in that can lead to disastrous results. So if we had time, I would tell you about the engineering disasters that occur because misunderstanding of very simple thing. The first Mars rover crash landed on Mars after 10 years of work, billions of dollars in its expenses. In the last minute, it just crash landed, and an investigation found that one group was calculating things in, say, kilograms, and another group was calculating in pounds, and they didn't cross-check that they all have to be measuring things in the same set of units. At any rate, so there went several $100 million and years of work over a tiny misunderstanding. So there is sometimes, doesn't matter how small the error is, the result can be disastrous. So we are responsible for everything we do. Yeah, we shouldn't think that a small error means small consequences. Typically, it's just the opposite. At any rate, so angle of elevation, we are looking for angle of elevation, and same issues as before. So what relationship connects this angle to this and to that one? Make sure it's just like the previous problem, isn't it? So sine of theta is a ratio of 14 to 16. So theta is sine inverse of 14 to 16. And then you go through, make sure it's degrees, and round it appropriately. Okay, so we learned about elevation and depression. We applied it to some simple problems, and the issue that I insisted was that you try to do it yourself, to translate from set of words to the picture. And I did mention that this issue becomes crucial in some high points of calculus. Topics there typically referred to as optimization problems or related rate problems. They are all word problems. You see an entire page of plain text, no formulas inside, short paragraphs, each of them describing a problem, and you have to translate that verbal description to a mathematical picture with variables and everything else, and then go about solving it. So this is a simple exercise to get you ready for that. Until then, good luck and God bless.